differential equation. For the curve shown in the diagram, the normal at the point P with coordinates meet the x-axis. The point M is the foot of the perpendicular from P to the x-axis. The curve is such that for all values of x, the area is equal to tangent x. Show that mn over y equals dy dx. Okay, so first of all, because the coordinates of P is xy, the point P with coordinates xy, this is xy, so that means this distance is x, this distance is y. So the height of the triangle is y, and this base of the triangle is mn. Now the dy dx is the tangent gradient, so the blue line is the tangent line, the gradient is dy dx. This is called the normal line, and normal is perpendicular to the tangent. The gradient is therefore the negative reciprocal, so minus 1 over the tangent gradient. And the gradient of this normal is of course negative because of the direction of the slope. It's got to be negative something. To find the number, we do gradient is rise over run, so the height divided by the base of the triangle, so minus y over mn is the gradient of the normal line here. Okay, so the normal gradient is minus y over mn. Okay, so now minus 1 over the normal gradient is the tangent gradient, and the normal gradient is again minus y over mn. So we have mn over y equals tangent gradient dy dx. So 1 mark to prove this. Show that x and y satisfy the differential equation. So the area of the triangle is base times height times 1/2. So the base is mn, the height is y. But from the previous part, we can replace mn with y dy dx. So we replace the mn with this, and we get what we need to prove. Okay, now solve. So this is the differential equation from the previous part, what we need to prove. We now need to separate the variables, everything with y on one side, everything with x on the other side. We can just multiply both sides by 2 dx, because on the left we cancel out the dx and the 2, so we have only y squared dy. Now on the right we have 2 tangent x dx. Now when we integrate y squared, we just use the usual rule, we get y cubed over 3. And when we integrate tangent x, well, first of all, tangent is sine over cos, and when we integrate something like this, we have to use this rule. So we have to make sure that the numerator is the derivative of the denominator. So in this case, our denominator is cos x, and the derivative of cos is minus sine. We have to make sure the numerator is minus sine, which means we have to modify this, multiply by minus again, which means we are not changing anything. But this form here is the f prime over f form, so we can get ln the denominator ln cos x. So that's the integral at the constant of integration on one side, on the right only. And then this is the general solution of the differential equation. To find the particular solution, we plug in y equals 1, x equals 0. So the y is 1, the x is 0. We can find the value of c. So use your calculator, you will get 0 here. And after we have c, we have now the particular solution. Now we just have to express y in terms of x. So we multiply both sides by 3. And then we take the cube root, and we're done. Alright, I'll see you again.